Okay, so now we're going to move on to domain. Domain, in some sense, is conceptually like bioclim. They're both what are called climate envelope methods. So climate envelope method is just like, that's where you've got your occurrence points in environment space, and you've got some algorithm for basically just drawing a box or boxes around them. It's basically just trying to come up with a deterministic way to convert this into a shape in environment space. And in bioclim, that was just basically drawing boxes. Domain's a little more complex, and there's an extra wrinkle here I'll get to at the end. Right, so we've got some combination of environmental predictors here. And let's say we want to know the suitability of habitat at this combination of environments. So for every point in environment space, we want to know the suitability of habitat under a domain model. And we do that based on its distance to the rest of the points. So I'm going to take this point, we're going to measure its distance in environment space to all of our other data points. But we're not going to do that with a straight line. So this is what's called Euclidean distance, just saying how far away is the nearest point going straight to it. We're going to use a modified Manhattan distance for domain. So Manhattan distance is when you actually travel along each axis independently. So you have to go along axis 1 and then along axis 2 to get there. So your Manhattan distance is going to be some function of this distance along this axis plus this distance along this axis, not the distance straight between them, right? Okay, so Gower distance is like a modified Manhattan distance. We don't have to get into how that's calculated. It's not super important, but we're basically going to measure that Gower distance between this combination of environmental variables and everywhere we've observed our species before. So the domain score is proportional to the shortest of those distances. So basically, the closer this is to the closest point where we've actually observed our species, the higher suitability we think this is, right? So this is basically just a way of saying everything that our species likes being the places we've seen it before, and the further you get from the nearest place we've seen it before, the less suitable we think it is. And that's fairly sensible. It doesn't require a ton of assumptions. Something interesting has happened, though, with domain models, which is that the domain models that are implemented in Dismo are not domain models. This is actually what a domain model should look like in environment space. It should be very tightly clustered around your occurrence points and should be a fairly complex shape, sort of reflecting the distribution of those occurrence points in environment space. If you actually make a model, a Dismo model in domain, and map it in environment space, its predictions of suitability, that's not what it looks like at all. The domain models, I think there's something wrong with the implementation of domain models in Dismo, but they actually come out looking a lot more like a bioclim model, just with much more kind of permissive climate envelopes. And what's gone on here, if I remember correctly, I actually did dig into this at one point and figured out what the issue is. I think the issue is they're actually treating each axis independently, which is not how you're supposed to calculate these Gower distances. So this has been broken in domain, I think, for in Dismo for 10 years now. I don't know that it's going to get fixed anytime soon. People have been using these models for a whole bunch of stuff, but it is worth knowing. The domain models in Dismo, and since E&M Tools uses Dismo, the domain models in E&M Tools actually are not domain models. They're just kind of a more permissive bioclim. So that's, like I say, that's worth knowing. I'm not sure anyone knows that but me and all of you now. But there you go.